Hello. My name is Matt Muller, and I am an SDE at AWS, and this is my presentation about generating a custom Ruby SDK for your web service or Rails API using Smithy, a modeling language developed by AWS. This will be the agenda for today's talk. I will briefly talk about who I am, then I will present an example use case and service for a generated Ruby SDK. I will then give an overview of Smithy itself and how it can be used to model and generate a Ruby SDK. Next, we will do a deep dive together into the SDK usage for both the public and private components. Finally, I will conclude the talk with some final thoughts. As I mentioned before, my name is Matt. I'm a software engineer at AWS working on the AWS SDK for Ruby team. If you've ever opened up an issue in AWS SDK Ruby on GitHub, you've probably interacted with me. I'm a Ruby advocate in our company. This is my first time professionally presenting, and it is my first time in Japan, so please go easy on me if I make a mistake. So without further ado, let's get right into it. Here's an example use case for why you might want to use Smithy Ruby. Let's say you and your team own a Rails API and is deployed somewhere. You and your customers may try to call the API in a number of ways, such as using curl or even writing your own connection code. This is not a great solution because they are too low-level or expensive to maintain. I think we can do better in this situation. You may want a full library to talk with your API, written in Ruby, of course, something that is extensible, easy to use, code-generated, and robust. We'll explore how we can do this with Smithy Ruby. So for this example, we're going to create a fake high-score service, following the command line guide in the Rails documentation website. First, we need a sample Rails API. If you haven't used Rails before, we'll just use the new command and pass it the -- API option with the name of our API. It creates a bare-bones service for handling requests and responses using JSON by default. Next, we generate the high-score model using a scaffold. Here, I specify a game field as a string and a score field as an integer. This creates a route, a controller, a model, etc., everything you need for a high-score entry. Next, we migrate the database with the db migrate command. This essentially adds the columns to the database for our new model. This is all standard for Rails applications. Finally, we run the server with Rails S. This starts the service on the localhost endpoint. Great. Now we can verify that our API is responsive. Here we just use curl against the endpoint in the route. We can see that we get back an empty JSON array because we have no high scores registered. Fantastic, everything works. But now let's focus on the customer who wants something easier to use, written in Ruby, of course. But first, what is Smithy? Smithy is a language for defining services and SDKs. Smithy models are defined using shapes. Shapes are named data definitions that describe the structure of an API. So in this example, a weather service shape is defined, and it has a city resource shape. The city resource is a way of describing operations on a city shape, such as get city and list cities. There's also an additional operation called get current time. There are many benefits to Smithy. Smithy is protocol agnostic. It works in any programming language. You can use it to describe services running in any environment, and it works with any transport format such as JSON, XML, or CPOR. Smithy models are designed to evolve. They can be extended through traits and its meta model. The extensible model allows you to avoid breaking changes for your customers. Smithy also supports API governance and customizable API standards and validation of your API definitions. Finally, Smithy is resource-based. Models are defined by resources and operations. This type of modeling gives you rich information about your model's transformations. Let's now install the Smithy CLI. You can install it in various ways, such as Homebrew on Mac or from source builds. You can visit Smithy's documentation for more details. Now let's define the high-score service as a Smithy model. We first create a Smithy file in a model directory. It defines the version and our namespace myapp. Then we can declare some imports. For this service, we're going to use the Rails JSON protocol, a protocol that we've implemented that interfaces nicely with Rails applications. The protocol is just a representation of the data over the wire, such as JSON or XML. You can implement your own protocol if you want. Most importantly, we define our service, the high-score service, with a high-score resource. We then annotate the service with the Rails JSON protocol to specify that the service implements this protocol. The high-score resource is essentially where we define our CRUD actions. We define a create, read, update, delete, and list operation for the resource, and the identifier will be the default ID that Rails uses for its models. Let's focus on create high score as an example. Here's the create high score operation. Create high score should be a post against the high scores URI. It has both an input and output shape, as well as a list of potential errors that might be raised. We can map our input to the same as our high score params in our Rails controller. Our output will be a serialized version of the high score model as JSON. If saving fails, our model will render errors with an unprocessable entity error, so we define that as a possible error in the model. Here are the input and output shapes. We specify that the input must require a high score member that maps to our high score param shape. Our output shape has our high score attributes as a JSON payload. The high score params are from our input. We take game and score fields to create the high score width. Our controller permits these two values under a high score hash. The high score attributes are from our output. It's really just a representation of our high score model. We have a mapping of our game as a string, our score as an integer, and we also include the created and updated at times as timestamps. Now it's time to build our Ruby SDK. To use Smithy, we first need to define the Smithy build JSON file. Here we declare a dependency on the Smithy Ruby Rails codegen package, which facilitates the generation. Next, we declare the model folder containing our Smithy file as a source. Then we declare a projection that will use the high score service as a generatable shape. Finally, we configure the projection with the RubyKaigi plugin that defines the service, the module name that we want, and other gem spec values such as the version and the gem name. Now we have our model and the Smithy build file. It's time to generate our SDK. We simply execute Smithy build, and we see in our output that the model was valid and it built successfully. Cool. So here's the output of that generation. We see that we have a gem and it has a gem spec. Everything here is fairly standard. We have a lib folder for our code and a sig folder for RBS. When we cd to the high score service output and start up IRB, we load lib and require the high score service. We can demonstrate usage by creating a client object. I will go more into detail about these components, but it works similarly to the AWS SDK for Ruby products. Here our client is configured with our Rails endpoint. We call the list high scores method. Similar to our curl output, we see that we get back a high scores array that is empty. Sweet. Next, let's create a high score. We can call our create high score method and pass it a high score hash. We have a game of Frogger and a score of over 9,000. We could see that the output has our data object with a new high score. It was created with an ID of 1, the game and score we define, as well as the created at and updated at times. There's also a location header that was parsed. Now if we list our high scores again, we can see that our high score is present. Cool. Now let's try to delete our high score. Maybe it was a mistake. We will call delete high score with our ID of 1, and we can see that we get back a successful response with no error and empty output. If we try to delete this high score again, we'll get back a not found error that indicates that the high score was not found. So how does it work? The SDK works on a middleware system similar to Rack. We have an input object and it's passed through middleware, with each middleware having a specific duty and delegating to the next middleware. We can see that our input flows through some initialization steps, validation, request building, retry handling, and finally it's sent to the service. The service response is then parsed. Maybe it's retried if it's a retryable error, and it flows out to the operation as output. Why go through all this? Well, there are many benefits to a Smithy Ruby SDK, which I will demonstrate. The SDK is easy to use. It has some rich features. It's highly extensible at runtime. It's code generated, so it's stable each time you make changes to your model. Finally, you can implement your own protocol and integrations at build time. Let's dive into the public features of a Smithy Ruby SDK. The most important piece is the client. It's your API entry point. It accepts configuration values such as the endpoint and other public features. It is responsible for calling your operations against your service. In our previous example, we created a client. That was this object right here. Next, there's config. Config objects allow you to configure options and components for your SDK. Config is passed into your client. You can even override your client configuration per operation call. So in our example that we saw before, the endpoint gets passed as config to our client and is used as expected. We can see that if we try to call list high scores with a different endpoint option, our client config is superseded with operation config. Obviously, this endpoint doesn't exist for us, so we get back a networking error. Next, let's discuss types. Types are very simple. They're basically data containers for the input and output shapes. You can think of them as glorified structs. In our previous example, when we created a high score, we got back a high score output type that had a nested high score attributes type. That high score attributes type has members for ID, game, score, etc. The SDK supports logging using a standard Ruby logger. The Ruby logger is helpful for request information, debugging SDK internals, or enable wire logging. In this example, we configure our client with a logger to standard out and the log level of info. We call list scores, and we could see some info-related logs with params, options, and the struct that was parsed. The debug level logs are more comprehensive. The SDK supports native errors and error handling. The errors are standard Ruby exceptions. Errors follow a hierarchy, which we will see shortly. Errors can be modeled or unmodeled and are handled the same way. In this example, we deleted our high score, but then we attempted to delete it again. When that second delete failed, we got our not found error. This error was not modeled. It is just a generic API client error with an error code of not found. We could have instead modeled this error and attached it to the operation, which would have returned a not found error class. This is useful if we want to add documentation, retry the error, or have some data attached to the error. To demonstrate modeled errors, let's look at the unprocessable entity error case. We can add a validation to our Rails model that validates the length of a game to be 2 characters long. Similarly, we can add a validation to our Smithy model to describe a service. Here we call create high score, and we wrap it in a begin rescue block. We use a game called X, which will fail validation. We expect to see some API error and print out the class and data. We can see that the error is an unprocessable entity error as expected. In the data of that error, we can see that the validation that Rails was provided, which was the game name is too short and must be 2 characters. Cool. This is an example of what errors are defined in the service. For every protocol, there's an error code method, which is responsible for mapping the HTTP response to the error class name. There's a generic API error, which all errors inherit from. There's generic client, server, and redirect errors for HTTP 3, 4, and 5x status codes. Finally, we have our generated model errors. In this case, we only have the unprocessable entity error. The SDK also supports custom HTTP client of your choosing. As long as it conforms to the interface, you can use it. We include a default client that uses net HTTP. Here we create a default HTTP client with a read timeout of 1, and we set the debug output to true to let us inspect the wire logs. We can also create and use a custom HTTP client as long as it defines a transmit method with request and response params. This may be useful if you want to control sockets or use other implementations such as curb or HTTP party or Faraday. We then initialize our API client using this HTTP client. And after calling list scores, you can see that the debug output was printed and the net HTTP client was used as expected. The SDK supports retrying requests and using different retry strategies. It will retry transient network errors and even errors that you model as retriable. You can also plug in a custom retry strategy that will determine what errors to retry and what backoff to use. In this example, let's make the unprocessable entity error retriable. In practice, this doesn't make too much sense because the validation will always happen. However, we just want to demonstrate that a modeled error could be retried. We could see that in our generated error that it has a retriable method that returns true and informs the retry logic that it is indeed retriable. Next, we set up our client. We enable wire logging so that we could see the retry count. We call create high score with an invalid game and look at our debug logs. We could see that we finished the request and that we had 2 retries, totaling 3 requests. The SDK has 2 default retry strategies, standard and adaptive. Both of these have some backoff algorithms and retry logic using retry tokens. Retry strategies are important to avoid service outages, as we don't want to just retry everything immediately. You can create your own retry strategy as long as it implements the 3 methods that it requires. Then you plug in the retry strategy that you want to use. When an operation is called, if a failure occurs, the retry strategy will determine if and when to retry and how long to wait between retries. The SDK supports a testing feature called stubbing. We can mock responses for testing in RSpec and Minitest. These mock responses do not use the network. Here we create a client with stub responses as true. When stub responses is on the client, we say that we want to stub list high scores with some data that includes a fake game and a -1 score. Then we specify the next stub as a networking error. We could see that the first time we call list high scores, the fake game is returned in the list. And then the second time we call it, we get the networking error. In your application, you can ensure that you can handle expected and unexpected responses from the service. The SDK supports hooks called interceptors. Interceptors are a runtime feature that allow you to hook into an SDK's lifecycle. You can modify the input, the output, request, and response objects at any stage of the execution. Here we define an interceptor called network interceptor. It defines two methods, read before transmit and read after transmit. This interceptor profiles how long the network call took. We capture the time before transmitting the request and the time after and subtract the difference. The interceptor also prints the request and response headers. We then register the interceptor in our interceptor list and then initialize the client with this list. After we call list high scores, we can see that the request and response headers were printed as expected, and the request time is also printed. These are the available hooks for interceptors. You can intercept before and after execution, serialization, signing, transmitting, deserialization, and any part of the retry loop. The SDK supports plugins. Plugins are distributable blocks of code that modifies and wraps config values. You can use them to bundle features for your customers to enable. In this example, we will take our network interceptor and wrap it in a plugin. We just add the interceptor to whatever interceptors are already configured to this client. We can instruct our customers to install and use this plugin if they just want to use network intercepting. We then register the plugin in our plugin list. We then initialize the client with the plugin list and then call list high scores. We can see that our plugin executes the interceptor as expected. The SDK supports waiters. Waiters are a feature that block code execution until some condition is met. They work by polling the service for this condition. AWS uses waiters for many reasons, such as in S3, waiting for a bucket to be created before you might want to put objects into it. For this example, here we define a waitable trait in Smithy attached to get high score. In that trait, we define a single waiter called high score exists. It has some acceptors which determine whether to keep waiting or not. If the high score is not found, we retry the waiting. If it is found, we return success and it stops waiting. To use the feature, we have our client. Maybe we have some async operation that creates a high score and returns what the ID will be. We then create a waiter with a max wait time of 10 seconds. We then wait for ID 1 to be created, which will wait up to 10 seconds. In this case, our high score service was created within the time limit and it returns true. We then wait for ID 2 to be created, but creation was too slow or it never happened. And we see that we get a max wait time exceeded error. The SDK supports pagination. Paginators will automatically paginate your service calls using continuation tokens. It will return enumerators for both pages and items of your API. So as an example, here we define the paginated trait on list high scores. We specify the input and output token to use for pagination, the page size, and optionally what items we want to model. We could see in the input that we add next token as a string and max results as an integer as query parameters. In the output, we add the next token as a string. To use paginators, we create our client again. Then we create our paginator class and pass it to the client. The paginator pages method returns an enumerator. The first item in this enumerator is our first page, and it has some amount of high scores up until max results. We can also call the items method, which returns the enumerator as well. The first item is just the high score as modeled. It does not contain the page or any metadata from the response. The SDK supports other features such as modeled authentication. You may want your service API calls to be authenticated. You can use Smithy to find authentication such as API key auth, HTTP basic or digest, or even SIG-v4. Rails provides mechanisms for most of these out of the box to add these to your API. You can also create your own auth scheme if you want. Dynamic endpoint resolution based on input at runtime or using complex modeled rules. You may want to route to a different endpoint based upon some input, which is helpful for client-side load balancing or A/B testing as an example. Custom DNS resolution using Ruby's Resolve or bring your own DNS resolver. Connection pooling, which can be reused in your custom HTTP client if you want. And finally, your next great idea. Now we will quickly do a deep dive into the internals just for our curiosity and to understand how the SDK works under the hood. These are helpful to know for debugging purposes, or especially if you're going to be vending this SDK to your customers. These interfaces are not intended to be used publicly. Builders are used for building transport requests, according to your protocol's rules. Here we see the builder for create high score. It's building a post request with a JSON body containing the high score. The high score params are built in a nested way, and then the body's fully built. Parsers are the opposite of builders. Here we are just parsing an HTTP response according to the protocol rules into a type that is eventually returned to the user. We also parse from headers like location and, of course, the body. Input is validated to have the correct type. Here we require the high score params are present and that it includes game as a string and score as an integer, and we get a helpful error if not. Params modules are just used to convert a simple Ruby hash as our input into a structured input type. This makes input and output both as types and consistent across all interceptors. That way you're not working with two different things such as a hash for input and a struct for output. This is the stubs module. For each operation, these classes are used to build default stubs from the stub responses feature we saw earlier. It essentially just creates an HTTP response with the stubbed output data that can be parsed as if it were a real response from the service to become output again. Finally, the whole backbone of the SDK is powered by middleware, similar to Rack. We create a stack of middleware and then add each middleware in a specific order. For example, we initialize our request, validate our input, build the request, calculate authentication, calculate our endpoint. We then add retry handling, sign the request, register the parse middleware for after we send the request, and then finally register the send middleware, which sends the request to the service. So what do you think? Smithy Ruby is currently experimental. We would love any feedback on this. It is entirely open source, and so is Smithy. The system will be the backbone of a future version of AWS SDK for Ruby. Thank you for listening. I am very excited to have this opportunity to speak at this conference and share my work with you all. You can find me on GitHub, but I have no other socials. If you're interested, the Smithy Ruby repo link is on the left. You can also play along with this demo by visiting the demo repo under my GitHub to the right. It has everything you need to get started with the high score service. Thank you again.